So this is what we're going to do in a slightly different way. So now we're going to be talking about the A. So we're going to actually put them both on the same graph this time. So we know that f of x equals root x. And that's going to be something like this over there. Now what we're going to draw is we're going to draw g of x, which is going to be 2 root x. So the a here would be 2. And what the a does is it does a vertical stretch. So that means that each of these points is going to be stretched. So the y values are going to be doubled. So it still starts at 0, it's still at 0, but it's going to kind of go higher. And it's been stretched. Conversely, if we had, what color might be different here? So we'll use a different letter. Let's say we have h of x is 0.3 root x. So it's now what happens is if it's been less than 1, it's been compressed. So it's going to be something like this over here. And the dividing line is essentially 1. So if it's less than 1, then you're in the compression zone. And if it's more than 1, then you're in the stretch zone. So that's f of x, 2 root x, 0.3 root x. A also does double duty though. So we're still talking about f of kx minus c plus d. So we know that our original function is f of x equals root x, and that's this over here. Now what we could have is we could have sorry, I was about to sneeze there. What we can have is f of x equals minus root x. And when there's a negative in front, that's going to be called a reflection. So that's a reflection. It's going to reflect over the x-axis. This is the x-axis. And it's going to look something like this. So that's actually down there. This is f of x. I should use a different letter. G of x is minus root x. And we could combine these things as well. So for example, we could say that h of x is negative 0.3 root x. So it's been compressed and flipped. So that would look something like this. And then we could have, and we could do a stretch as well, of course. So it would be maybe j of x is minus 7 root x. So the negative means that it flips. It's reflected over the x-axis. And that would be our j of x. To summarize what happens with the a over here, so this over here is a compression. It's a compression. If it's more than 1 or less than, that should be a negative 1. That's going to be a stretch and a stretch. And if it's anywhere in this zone over here, it's going to, so this is for A. We're doing for A. This is going to be a reflection over the x-axis. And that's what A does. And if it's exactly 1, so if it's exactly 1, then there's no stretch or compression. Same thing with -1, also no stretch or compression. And if A is 0, you actually don't have a graph. It's been destroyed because it's going to be 0 times, all of this, which is actually a line and kind of boring.